Now here we have a particularly challenging kind of problem that we might deal with when we are talking about um, conduction. And that's when we have to conduct through two different slabs of material. The key idea here is that we don't really know the temperature here in the middle, but we do know that the power transported through the first layer has to be the same power, the same rate of energy transfer through the second layer. Otherwise, somewhere in here we'd be heating up and cooling down. So we want the power at the steady state. Well, that means whatever the temperature is there in the middle, the power through the first part, K2, is K2 times the area over the length times T hot minus Tx. And that has to be equal to the power through the second slab, K1 times area. This is length 2. This one is length 1. Times Tx minus T cold. And ultimately, we would like to be able to solve for that power. And say that the power is equal to some K effective over L effective times A T hot minus T cold. Well, if we use some of the insight we gained in electricity and magnetism, we could try isolating the Tx minus Tc and the T hot minus Tx, and then just adding them together. So let's group all of this. What I find is that A T hot minus Tx is equal to the power times L2 over K2. A Tx minus Tc is equal to the power times L1 over K1. If I add those together, I get A times T hot minus T cold because the x's cancel out is equal to power times L2 over K2 plus L1 over K1. And that should equal power times L effective over K effective. So we can just add these quantities, length over conductivity, which is essentially like a resistance. We can add them when they're linked together in series like this. It turns out there's a special name for that. That's called the R value. And it's more useful when we talk about how well insulated a house is to talk about the R values, because if we add another layer of insulation, we can just add that R value on. So to review how this works, the R value is just equal to the sum of lengths over conductivities, and the power is going to be equal to the area times the temperature difference divided by the R value. So a larger R value will result in a smaller conductivity, a smaller rate of power exchange.